Graphical features and terminology. So it says up here at the top that there is a lot of terminology associated with the graph of a function. Sorry, I had to get my stylus going there. So lots of vocab. Okay, many of the terms have names that are descriptive, but still, work is needed to master these ideas. So we've got to increase our vocab here in order to talk about these functions. So we have this function, y equals f of x, is shown graphed below over this interval from -7, which is less than or equal to x, which is less than or equal to +7. So I don't know what the rule is or what the equation is of this curve. I just know what the curve looks like. And they're telling me that it's graphed, and we can see that it's graphed from here. It starts here, and it ends here. So that point right there on the x-axis is -7. And this point where it ends to the right is +7. So it says, find the maximum and minimum values of the function. So we've got two words here, but these are fairly descriptive. Okay. State the values of x where they occur as well. So a maximum point. Okay. So where is that maximum point in this graph? Meaning the highest point. Okay. So the max would be the high, and the minimum would be the low. So your maximum point clearly occurs right up here. That's the highest point of the graph. So what is that point? That point is -1, 7. Okay? So -1, 7 is your max. And then the minimum, or the lowest point, so when I look at this graph and I find the lowest point on this graph, it's right here. So in what point is associated with that? That would be -5, -1. -5, -1 is the minimum point on the graph. So the max is the high, the min is the low. Part B says, what is the y-intercept? Okay, so that's a term you're familiar with. Okay, the y-intercept, you talked about the y-intercepts of linear functions. So the y-intercept for any function still has the same meaning. So let's answer the first part of that question. What is the y-intercept of this function? Well, the y-intercept is where the graph crosses the y-axis. So right there, there's our y-intercept. Just going to abbreviate, INT. What is that y-intercept? Well, the y-intercept always is 0, something. So we're at 1, 2, 3, 4, 5, 6. So that y-intercept is 0, 6 is the y-intercept. And explain why a function cannot have more than one y-intercept. Why couldn't we have a function have more than one y-intercept? So don't draw this on your paper, but I'm gonna draw something. So say I don't know, say I had some function that looked kind of like that. Do we agree that that has more than one y-intercept? Well, in this case, this one's got 3 y-intercepts. So why are they saying y function can't have more than y-intercept? Because it wouldn't be a function anymore, right? Wouldn't pass that vertical line test. Okay, so our explanation is it wouldn't be, a function with more than one y-intercept. Okay? Next part, we're still talking about this same graph. It says, I'm going to just erase that purple function that I graphed on there. Okay. Give the x-intercepts. So if the y-intercepts are where the graph crosses the y-axis, the x-intercepts are where the graph crosses the x-axis. So jot that down if that's not something that you're familiar with. Okay, it's where the graph crosses the x-axis. And then it goes on to say, these are also known as the function's zeros because they're where f of x equals 0. So we've got two important things there. They're also called zeros. So right now we have two synonyms. X-intercepts equals zeros. Okay? Whoops, ES. They mean the same thing. Okay? Two different words still have the same meaning. Okay? Synonyms. Same meaning, different word. So it says give those x-intercepts. So where does this graph cross the x-axis? So I see it crosses the x-axis there, it crosses the x-axis there, and I don't see any others. So that right there is an x-intercept, and that one there is also an x-intercept. And what are those x-intercepts? They are negative 6, 0, and negative 4, 0. So do you see that pattern? Anytime it's a y-intercept, it's going to be 0, something, some y value, and your x-intercepts are going to be some x value, 0. Okay? All right. So now it says, would you characterize the function as increasing or decreasing on the domain interval -5 is less than or equal to x, which is less than or equal to 1? Explain your choice. Well, holy smokes, there's a lot going on in that question. I'm sure you would agree. So let's sort of pick it apart and let's look at this graph again. So let me get more of it on our screen. And I'm going to do some erasing so you guys can really visualize what we're talking about here. I'm sure your handwriting on your paper is a lot neater than mine right now. Okay. So it says, which characterize the function as increasing. Okay, increasing, you know what that means. Means getting larger. Decreasing means getting smaller. On the domain interval from -5, which is less than or equal to x, which is less than or equal to 1. So let's find out where they want us. What part of this function here, this funky looking curve, do they want us to focus in on? So they want the x values from -5 to -1. That's what they're telling us. So -5, 1, 2, 3, 4, -5. Okay, so this chunk all the way up to where x is -1, which is right here. So would you characterize that sort of slice of the graph? I'll put some little arrows on it. What would you say? Would you think that that is increasing or decreasing? Remember, we always read graphs just like we read our words from left to right. So that looks like it's going uphill. We have a rate of change that is increasing. Okay, so it's increasing. And then it says explain your choice. As x values increase, okay, our x values went from -5 to -1. What's happening to the y values? Okay, the y values are increasing as well. So as x values increase, the y values increase too. I'm just going to use a little arrow to indicate increase. Okay. Next part, it says one additional interval over which the function is increasing and one over which it is decreasing. So they want us to look at that function again, and where else do you see it increasing? Where else does the rate of change look like it's increasing? So I would say it looks like it's increasing here. Would you agree? Looks like we're going uphill. So from here to here. So what interval is that? That is x is 2 to, let's see, 3, 4, 5. 2 to 5. Okay. And it would be increasing. 2 to 5. We can use our interval notation, okay? Or we could use our inequality notation. 2 is less than or equal to x, which is less than or equal to 5. Just another way of writing it, interval or our inequality. And then they want an interval where it's decreasing. Okay, there's a couple there. We could say that it's decreasing here. It's also decreasing in there. And it's decreasing there as well. So you have, you can decide which one you want to write. I think I'm going to go with this middle piece. And this middle piece starts at x is -1 and decreases or falls till we get to where x is 2. So from -1 to 2. -1 to 2. Okay? All right. Let's talk about some more. It says the following points are known as turning points. Okay? Each can be classified as relative max or relative minimum. State which you think each is. So I have this point here, -5, -1, and let's look at it on our graph. Would you think that it's a relative minimum or a relative maximum? Min means a low, and max means a high. -5, -1. So I go back here to this graph, and I'll erase. -5, -1. 1, 2, 3, 5, -1. Okay? Would you say that that's a minimum point or a maximum point? A relative min or a relative max? I would say it's your low point. So that's a relative minimum point. Now let's look at this next one. -1, 7. So -1, 7, what would you say about that one? Okay, that's definitely going to be a relative max. 2, 2. So 2, 2, right there. Okay, that's a low point on the graph. It's not the lowest. It's not the minimum. Okay, but we could consider it to be a relative minimum. It's a low point. It's just not the lowest. Okay, so we'll say that one's also a relative min. And then 5, 5. Let's go back up. 5, 5 is right here. Would we consider that a maximum or a minimum? Meaning it's not the max, because this one is the max, but this one right here is still a max. It's still a high point, but it's considered a relative max. Okay, so that one is a relative max. Okay, so back here on these, this -5, -1, they would consider it a relative min, but I would say that -5, -1, that is the min. Okay, it's the lowest point on the graph. Same thing with this -1, 7. It's the maximum because it is the highest point. And these two are considered relative. Okay, they are minimums and they are maximums, but they're not the highest or the lowest. Okay. All right, so now it says, let's get some more practice with piecewise defined functions. We talked about piecewise functions, and they're literally pieces, okay, of functions, parts of functions, okay, and we're going to toss in some other function terminology in here. So exercise 2, it says, consider the piecewise linear function given here. And how do I know that it's linear? So when I look at the first piece of it, that x plus 3, that's linear. That's in the form y equals mx plus b. And then I look at the second piece of it, 6 minus 2x, that's another linear function because, again, it does have or resemble y equals mx plus b. So it says create a table of values below over the interval from -4 to 4. So why do they give us that? So our table is just going to start at -4, and it's going to include every consecutive integer all the way up to and including +4. So it says the rule or calculation. So we talked about this in our last lesson. So -4. We've got two pieces of our function here. We've got this x plus 3 for when x is less than or equal to 1, and then we have 6 minus 2x when x is greater or equal to 1. So -4. Where does -4 lie in our interval here? Is -4 less than or equal to 1, or is -4 greater than or equal to 1? It's certainly less than, so that's the piece of the rule that we're going to use. So we're going to use that x plus 3 part, and we're going to say, oops, -4 plus 3, which is going to give us -1. So we're going to end up with a point of -4, -1. And now I do the same thing with my -3. So -3, again, -3 is less than or equal to 1. So again, I'm going to use that piece of the function. -3 plus 3, which gives me 0. -3, comma, 0. All right, so we get the idea here. Let's go to our calculator and let's type in that piecewise function. So while my calculator is warming up and while you're grabbing your calculator, I'm going to pause. Okay, so we're on a graphing page, and I talked to you about graphing a piecewise function. And we go next to the 9 key, and we bring up this right here. That's going to allow us to type in our piecewise function. So the first piece is x plus 3. And then the domain is x is less than or equal to. Remember, those symbols are under the control key. So we need less than or equal to 1. And then the second piece to this, 6 minus 2x. And the domain for that piece is x is greater than or equal to +1. And once I hit enter, okay, I get a look at my graph, got my label here, and then I can go to my table. Remember, I said to find your table is Control T. And what they wanted us to put on our table was from -4 to +4. So go ahead and write down your table. Remember, you just kind of arrow through it all the way up to when x is 4. We want all of those values in our table. So we let the calculator do that calculating for us, and that's totally fine. So I'm going to go down and fill these in. -2, 1, -1, 2. You guys don't need to hear me talk on this. You can see. Okay? And then we could go ahead and plot those points to get that graph that's on our calculator. Okay? So when I draw that in, okay, okay, use a straight edge, and drawing that in, I'm going to extend that graph, okay? And now let's answer some questions according to that graph. It says state the zeros of the function. So remember, the zeros are where the graph crosses the x-axis. Okay, where the graph crosses the x-axis or the x-intercepts. So where are those x-intercepts? They're right there and right there. And those values are x equals -3 and x equals +3. You could also write them as points. You could say -3, 0, or 3 comma 0. Either one is acceptable. State the function's y-intercept. So where does this graph cross the y-axis? There's our y-axis, or our y-intercept, and that is where y equals 3. Or you could state that as a point as well, 0 comma 3. And it says, give the interval over which the function is increasing, and then they want one where it's decreasing. So where is it increasing? Where is that rate of change, or the slope, increasing? Well, it's increasing right there. Okay, so how do I indicate that? We've got this arrow here on the end. So what's happening? Where is it coming from? Remember, we read from left to right. This right here, my x-axis, focus in on the x-axis. So it's increasing from negative infinity all the way up to where x equals what? Where x equals 1. That's where it stops increasing. So we could say it's increasing when x is less than 1, or if we wanted to put it in interval notation, we'd say negative infinity to 1. Okay, and then where is it decreasing? So the other side of it, okay, it's decreasing. Okay, we have that negative rate of change, and it starts decreasing from 1 down to, on our x-axis, positive infinity. Okay, so it's x is greater than 1, or in interval notation from 1 to infinity. Remember, these are our x values. Okay. Part E, it says give the coordinates of the turning point. Okay, the turning point is where it goes from increasing to decreasing, and classify it as a relative max or a relative min. So that turning point was right up here at the top, and that turning point was 1, 2, 3, 4, 1, 4. And would you consider that a relative min or a relative max? So my turning point's 1, 4, and I would say that that's a relative max. I'd be okay with you saying that that's a max there. That is the highest point on the graph. There is no other high points on the graph. Okay. Now it's the last couple questions. And it says, use your graph to find all the solutions to the equation where f of x equals 2. So in other words, what are all the x values that go with a y of 2? So what x value goes with a y of 2? And is there another one? I don't know. I don't have the graph in front of me right at the moment. So when I look at it and I go, where does y equal 2? Y equals 2 all along this line. So where is it crossing our graph? Where is it crossing our function? It's crossing our function at 2. And then it's also crossing our graph at -1. So -1 and 2, okay, are our solutions, okay, when f of x equals 2. Now it also states, it says, state the interval over which the function is positive. Okay, so this is changing it a little bit. The interval over which the function is positive. How can you tell this quickly from the graph? So where is this entire graph? Okay, where is it positive? So when I look at this, we've got to focus in on the x values that produce a graph above the x-axis. So where is it positive? You've got to look to see where it's above the x-axis. So I'll erase so we can see this a little bit better. Where is this graph above the x-axis? Well, this right in here. Well, I should change my color. Okay, it's above the x-axis here, and it's above the x-axis there. It's negative below the x-axis. Okay, so what is that interval where it's positive? So it goes from -3, okay, x is -1, -2, -3, up to +3. Oops, up to positive 3. So the way we could state that as an interval, we could say from negative 3 to 3. And why don't I use brackets on that? Well, I'll also put this in inequality notation. Why am I not putting an equal to? Because at negative 3 and at 3, what's the y value that it equals? The y value right here is 0. And is 0 positive or negative or neither? Okay, it's neither. So that's why I can't put that it's positive there. So I'm going to use parentheses because it's not equal to. All right? Gets really close to that negative 3, and then it becomes positive. All right? Nice job, guys.